In this video, we discuss a convenient way to design a buffer. Let's first define what a buffer is. A buffer is a combination of a weak acid and its conjugate base, or a base, which is weak, and its conjugate acid. And we have seen in a prior example that when you have reasonably equal concentrations of the weak acid and the conjugate base, or the weak base and the conjugate acid, and those concentrations are high, and that means about 0.1 molar or above, it turns out that those solutions that contain both the acid or base and the conjugate pair, those resist addition of a little bit of acid or base reasonably well, and that is very useful. So the question is, well, how do we design these buffers? How can we make them? Okay, so as an example, we can put here, say, hydrofluoric acid and then fluoride, and here we can use ammonia and ammonium ions. So an easy way to do this to make this type of buffers would be to simply take a solution of the weak acid, hydrofluoric acid, and then add a solution of a salt of the conjugate base, say sodium fluoride, and then have the same concentration of each, and have those concentrations be high, and then there you have it, right? So that would be that would involve mixing two solutions, again, one with the weak acid or the weak base, another one with a salt of the conjugate pair. But there's actually another way to do this, which involves doesn't require two solutions. It actually just involves either having the acid or the base, and then generating in situ the conjugate pair by adding either a strong base or a strong acid. Okay, so we're going to see how this works by just taking, say, hydrofluoric acid and then adding a little bit of base. Okay, so let's suppose that you have hydrofluoric acid, and that concentration is about 1 molar. Okay, that's a solution of 1 molar. And again, well, when you try to do this, see if you can get a buffer of this, what you will have is that this acid is pretty weak, right? So you get protons and fluoride. But to get a buffer, you actually need a high concentration right here. The problem with the acid by itself is that, well, this K sub A is very small. K sub A is 7.2 10 to the minus 4. And what that means is that at equilibrium, you're going to have very little fluoride. What you need to do is have quite a bit of fluoride. As a matter of fact, you would like to have something that is very close to this concentration of hydrofluoric acid. Right, so then a way to do this is to say, well, I can actually have here hydrofluoric acid, but then add a strong base, like sodium hydroxide. What happens with the strong base is that it reacts completely with the acid, and of course the products of these are going to be sodium fluoride and water. But sodium fluoride is a strong electrolyte, so that means that it's fully dissociated to sodium plus and fluoride minus. Okay, so this is a way to actually start from the acid and start getting the conjugate base, which is what you need for the buffer. Okay, but you have to be clever about this. If you add one equivalent of the base for each equivalent of the acid, the problem here is that this reaction will fully displace to the right, and that means that yes, you will have a lot of fluoride ions, but you won't have any hydrogen fluoride left, so then you won't have a buffer. Remember that you need both the weak acid and the conjugate base in high and equal concentrations, right? So the way to do this is not to add one equivalent of base for every equivalent of acid. Instead, what you would like to do is add half equivalent of base for each equivalent of acid, right? So to do this correctly, the way that you would do this is say, well, if I have 1.0 molar or 1.0 mole of hydrofluoric acid, I need to add 0.5 mole of sodium hydroxide. All right, that is the half equivalent. And what I get at the end of the reaction is that, well, this half mole will react completely with just half of the 1 mole that I have of hydrofluoric acid, and that will provide 0.5 mole of my sodium fluoride. And because hydrofluoric acid is in excess, then you will have here half mole left, and then no base left, and then water doesn't matter. So that is exactly where your buffer is. Now you have equal amounts of the acid, weak acid, and the conjugate base, and then you're ready to go. right? So again, in this video we have explained how to design a buffer by, instead of mixing two solutions, one with the weak acid or base and another one with a conjugate base or acid, instead you can generate the conjugate pair in situ by taking a solution of a weak acid and adding half equivalent of strong base, or if you want to make a basic buffer, you would take an equivalent of the weak base and adding half equivalent of a strong acid.